And my topic is From Research to Global Business, the case of biotechnology sector. And what I'm going to speak is very briefly stated here. First, I will say some words about the knowledge-based economy. Then I will continue to describe what it means to be in a knowledge-based economy in terms of innovation policy and what sort of implications there might be in terms of policy. Then I will briefly describe the situation and development in the Finnish biotechnology sector in order to contextualize my two case studies that I will then quite briefly describe, and then I will, at the end of the lecture, draw some policy conclusions on the basis of the two case studies. I've kind of figured out that this lecture might take an hour or a little bit less, so I will very briefly refer to my empirical cases, but I have publications on them. So those of you who might be more interested in the very kind of details of those cases, I have one copy of each paper here with me, so I can give it to you and you can perhaps make copies, or then I can email it to you if you give me your card or email address or something. So let's go on. In our time, it's quite usual and it's quite widely held idea that we are living in the era of knowledge-based economy. And the concept of knowledge-based economy belongs to a group of concepts that have been developing since the 1960s or 70s that address the central role of knowledge and know-how in economic life and in social life, kind of societal life all together. And how does that kind of present itself in terms of economic production? Here are three ways to see the relevance of knowledge and know-how in terms of economic development nowadays. The first of these is the increasing complexity of products. If we think about, let's say, automobiles, which is pictured there, or airliners or any like these sorts of technical artifacts, nowadays they are very complex indeed. They are very many different kinds of computer systems are embedded in them, and so the increasing complexity of products makes it kind of necessary to have very much different kinds of knowledge and understanding and kind of abilities to develop technologies. Also, what has been going on in production of goods in the societies, in Western societies, is that the production has gone from mass production, which is kind of production that you produce similar kind of product to a very large amount of consumers. It has went to more customized mass production, where you have kind of very many kind of, let's say, telephones, and they have core technologies quite similar in each telephone, but then they are mass tailored to different uses and to different segments and to different user groups. So you have, let's say, Nokia, for instance, during the late 1990s, it must have had nearly 200 different kinds of telephones. They had some core technologies, but still they were kind of marketed to different segments of the users. And then there is, in various areas of science and technology, there is very rapid development of sciences and technologies, and the technologies have become so complex that no one alone can kind of master them. Let's think about, well, biotechnology, for instance. There are so many different kinds of specialisms within that large field that in order to make use of it, you need to kind of have a large basis of knowledge, and you need to collaborate with other people because specialism, as a specialist, you usually are quite limited. So the picture, to get a kind of a full picture, you need kind of many people and different kinds of competencies that must be combined. And the fourth issue, which is relevant here, is the shift in production from goods to services. Usually industrial societies, factories, it was different kinds of goods were produced in factories and then sold to customers, but nowadays it's where the companies get more of their revenues. It's not so much anymore production of goods, but instead kind of service contracts that are embedded in the goods they sell. Let's say, for instance, we have a paper factory and it wants to make its production process controlled by computers. So there is a company which sells for the manufacturing plant or the manufacturing company this sort of automatic computer system which controls the production. But what is more important for the company of selling this computer system is that it usually has very long-term, extensive service contract, and that makes more money for the company than the simple kind of automation system. So we have this sort of a shift towards from material production to this kind of services. And what does all this mean in terms of economics and economic production and economic dynamics is that because it is very difficult to master all these things within one company or by, let's say, a small group of specialists, usually companies and people, they have to form collaborative networks with other specialists. And these networks are usually, they can be very heterogeneous in terms of, let's say, in the field of biotechnology, they may contain researchers, they may contain universities, they may contain government agencies, they may contain hospitals. Very different kinds of actors collaborate in these networks, and the most recent development here is the involvement of end users also in building new innovations. This is what is called open innovation, and user-producer interaction is also very central topic in nowadays science and technology studies. And what I'm claiming here now, and this has some research background also in science and technology studies, is that biotechnology as a field of technology is paradigmatic example of this kind of a networked business and networked field of science and technology. It is relatively new. It kind of in the modern form, biotechnology emerged in the beginning of 1970s. It's very fast developing field of science with very specialized knowledge based, and at the same time it has more or less lucrative business opportunities. So it's kind of very central also from the policy point of view. And there is actually, in science and technology studies, there has been very much research on biotechnology and various kinds of collaborative structures and collaborative activities within that field already from the early 1980s, and especially that research has been done in the United States, of course, which kind of was the home of the biotechnology industry and so on. So then let's go on to a little bit policy implications of this. The traditional science and technology policy was quite much about allocating funds in order to advance scientific development and development of new technologies and new instruments and that sort of things. Because of this knowledge society development and the fact that innovation has become all the more important in terms of nations' competitiveness in the global scale, there has been a shift in policy framework from traditional science and technology policy towards more broad-based innovation policies. And here, governments nowadays are focusing more on kind of generating more positive framework conditions for innovation on a broadest terms. I mean, attention is paid to education, to creating top-level research, but also to create supportive normative systems for companies to operate. For instance, quite recently, Finland transformed its IPR legislation so that it would be kind of more in line with this kind of innovation policy framework. Also, issues about venture capital funding of emergent technology-based companies is very central issue, and all these issues are now on table, and governments are kind of trying to create suitable and supportive environments for companies to operate so that there would be kind of innovations. And one policy framework that has been used very extensively is the so-called National Innovation System. It was propagated very heavily from, let's say, late 1980s by the OECD, and it was developed within the OECD committees and work groups, and many countries have adopted it as a kind of main policy framework. Also Finland has kind of, in the early 1990s, it kind of reframed its whole science and technology policy in terms of national innovation system. And nowadays it's also used by OECD as a kind of policy tool to develop different national economies and policies of different countries. It was just last year that OECD published a report about national innovation system of Russia and gave kind of different kinds of suggestions of how to develop a Russian innovation system. So that's very widely used, but one peculiar issue here is that we are speaking about national system. And if we think about the biotechnology or what I was speaking about, a knowledge-based economy, that's more a global issue. I mean, economy is global. Businesses and companies operate on a global scale, operate on a global basis. Researchers work on a global sphere, but national policymakers are kind of sticked to this national innovation system approach. And that's kind of one interesting topic that will be touched upon later on in this lecture when I describe more about these concrete case examples that I have studied. And what I'm going to now kind of do in this lecture, I'm going to start moving towards biotechnology, and before that I will kind of tell you what are the purposes of this study in relation to the two companies that I'm elaborating on. I have done a longitudinal study on the development of these companies from their very early stages until they have become a little bit mature. The trajectory I've studied is a little bit more than 20 years for other company, and for the other it's 15 years. And I'm going to describe very shortly different developmental stages these companies have went through. And while doing so, I hope to illustrate the complexities they have encountered in their careers, and also the advantages and opportunities they kind of have also encountered. And on that basis, it's maybe possible to draw some policy implications, and it's especially so because if we take National Innovation System as a kind of a policy framework, and by the way, National Innovation System, it's an idea that each and every institution of the society is relevant from the point of view of innovation, and interactions between these each and every kind of institution are what kind of determine the ability of a society or the nation to create innovations. So it's very comprehensive kind of an idea, systemic kind of concept to think about policies. So I will draw some implications from my case study perspective, precisely because companies are usually regarded as very central actors in the national innovation systems. They should be kind of those agents who make economic use, who kind of transfer scientific research and results of results created in universities and research institutions to the sphere of economy. So a little bit contextualization of these companies in terms of Finnish biotechnology sector. Here is kind of the areas in which Finnish biotechnology companies operated in the early 2000s. And as you can see, the one company I studied was pharmaceutical company, which is kind of one of the major areas where Finland has tried to establish a new industry. So my other company comes there from, and the other company, which I call here reagent company, is a kind of company that operates in multiple fields. It operates in producing diagnostic services for customers. It has a background in developing enzymes and reagent to be used in biotechnological research at laboratories, and quite recently it also established itself as an equipment developer and equipment producer. So it covers these areas. This kind of a picture of Finnish, I would rather, before going forward, I would make a couple of more points from this slide too. If you take the right hand small kind of a ball there, you can see that what is the structure of biotechnology sector in Finland. It is so that most of Finnish biotechnology companies are very small. As you can see, 44% of the companies are employing less than 10 people. So they are really small entities. They are usually kind of research-intensive spin-off companies of some sort, and there is only a couple of companies that employ more than 250. And even if we say that 250 or more, let's say a couple of thousand employees is a big company in terms of Finland, it's a very small company in global terms. If we take major global pharmaceutical companies, they employ more than 100 people. And the largest pharmaceutical company in Finland employs only something like 3,000 So that's even a small player in the field. So that's kind of central characteristic of Finnish biotechnology sector, that nearly all of the companies are very small. But Finland is an interesting case because since the let's say mid-1990s, it has done a lot to create itself a biotechnology industry. Actually, this policy development started already earlier in the beginning of 1980s. From the beginning of 1980s, there has been very many funding programs in order to build infrastructures in biotechnology in Finland, business incubators and science parks and all these kinds of organizations that you will find in any country nowadays. Also, there has been for a long time R&D funding and more basic research funding directed at biotechnology. But during the mid-1990s, even more funds were directed at developing this field in Finland. I once counted that during the 1990s, the funding for biotechnology totaled, I mean the research funding and research and development funding totaled something like 400 million euros. And public capital investments in biotechnology companies totaled something like 100 million euro. That's a lot of money in terms of Finnish economy, but it's not that much. Also, again, if we take a look at the kind of the monies that are needed in order to build biotechnology industries on a global scale. If we just think about how much nowadays one biotechnologically developed drug costs, the whole amount of money that Finland spent during the 1990s is about half of that. It's about $1 billion that it takes to nowadays to build one biotechnological drug that will be sold in pharmacy. So that will be kind of ready and sold to final end users. So that's very... But despite that, there was a very strong hype in Finland during the 1990s. And people really believed that it is possible to establish a new industry into the country. And this is in Finnish, and this comes from the major national newspaper, Helsingin Sanomat, and the title says that is new Nokia breeding in Finland. Nokia was at the time kind of the very large Finnish company, very important to the economy and very strongly developing company. And so there was a kind of quest for new Nokias in Finland. And experts really believed that biotechnology could be another area where another major company would evolve in Finland. It says in the second title that experts believe that biotechnological drugs may be the next success story. So that was kind of a general idea behind these investments during the 90s. And what then, when the investments were made during the 1980s and 90s, you can see here the kind of a increasing trend. This picture shows you the establishment of biotechnology companies in Finland, and there is growing trend since the early 1980s of establishing new biotech companies in the country. But then the hype came to an end by the turn of the millennium. It has background in the kind of a collapse of ICT bubble in the United States and other parts of the world in 2000, and it then spread also to biotechnology sector. And as you can see, the number of new companies dropped very significantly, and after that the sector has been in problems in Finland in terms of getting venture capital investments. And of course the research is going on, and the kind of R&D is going on the basis of funds allocated by the major science and technology funding agencies in the country, but we don't have biotechnology industry in the sense people hope to have it. And here is another picture which kind of tells you about this. This is the development of Finnish industrial structure after the Second World War, and as you can see, the dark line there, that's electronics, and you can see the exponential growth of the area during the 1990s, and it's partly because of Nokia in Finland. And it was kind of believed that something similar could take place in biotechnology, which was not the case. Still, our economy is based on pulp and paper industries and machinery and metal industries, which are these days also encountering problems because of globalization. But anyway, this idea didn't quite succeed. So the current situation then, so this is biotechnology on the very small line on the in the red red balloon. Okay. The current situation on a global scale, the biotechnological industry and pharmaceutical industry is growing. It has a history of very long and steady growth, and it does grow all the time. But Finland is not in this bandwagon. We can see very clearly. And one reason, evidently, is that the increased costs of creating, for instance, new biotechnologically engineered drugs, which is huge. It's really huge. And Finland, in terms of biotechnology, Finland is a very small market area with small companies, so it's very closely tied. If we are going to have that industry and those companies that we currently do have, they are very intensively and closely tied to the global developments. They must be companies that operate on a global scale from the very beginning, because there don't really exist local market. There are no major pharmaceutical companies or biotech companies in the country that would help small companies kind of broken to the global scale. So these small companies must start working on their own on a global scale from the first day of their activities. Now let's move to the case examples. The first case example comes from pharmaceutical area. This is a pharmaceutical company that was established in 1994 at the University of Turku, Western Finland. It was based on a research that was done on a soil bacterium at the University of Turku, and the researchers working there developed a method of growing that sort of bacteria and getting that bacteria to produce antibiotics. And these antibiotics are substances that can be used as in cancer treatment. So they are kind of intermediate products when you are developing cancer drugs. And by the way, the picture on the upper right-hand side is picture of these bacteria that are called Streptomyces Galileus, and below that picture is a kind of a pilot scale fermenter where these bacteria can be grown, and then they kind of produce these certain kinds of antibiotic molecules, example of which is also over there in the lower part of the slide. And then they are kind of manufactured into final products that are then used by patients. So this is very typical Finnish biotechnology company. It is relatively young. It has few employees, actually less than 30 employees. It's very R&D oriented. It didn't have, when it was established, it didn't have finalized products at all. It started to develop those products on the basis of capital investment from Finnish Innovation Fund Sitra, and on the basis of much research funding from Tekes, which is the kind of major technology funding agency in the country. And the company really had kind of high hopes of its future, and the investors too. They kind of thought that they could establish a drug factory in the country, producing these antibiotics, and then selling them to other companies that would make them into final medicines. But it turned out to be that was not possible, quite much because of the amounts of money that would have been needed in order to establish a drug factory. So this story is much about gradual downscaling of an ambitious business plan. There were huge hopes, and what came out of this company after some 15 years was more or less a small contract manufacturing company that uses its facilities to produce antibiotics and other toxic substances for international customers. And it's not a major player in any sense in the Finnish economy. It still is a company of something like 25 employees operating nearby Turku and so on. And so if we then take a look at the major challenges the company encountered during these 15 years, and we can understand something about the problematics it had to face. I have in this slide collected these challenges into three categories: the firm-level challenges, national innovation system level challenges, and supranational level challenges. And the most of the challenges perhaps were at the firm level. First, when the company was established, its production technology for producing these antibiotics was unfinished. So it only produced 30% purity of these molecules, when in order to have such kind of a manufacturing system that you could have that you could ultimately sell the products to other companies, you should have had something like more than 90% purity of the final product. So there was huge work to be done in terms of developing technology. Because of the technology was unfinished, there was a lack of quality assurance system, a license for drug production for this firm. In Finland, you cannot produce drug substances unless you have a license for that production. And in order to have a license for drug production, you need to have good manufacturing practices that are and you need to have quality assurance systems and all these kinds of standardized things in your production plant. And the company, of course, didn't have these because they even didn't have working technology to create the substances. And finally, because this was a university spin-off company, the entrepreneurs that were managing this company, they were former academics. They didn't have experience in business circles. So they were learning to operate in business sector, and they didn't have much knowledge about the business area, because although you are a researcher, it's completely different thing to be an entrepreneur and kind of a business actor in the same field. It's whole new game. It's very different. So these were firm level challenges the company encountered. Then if we think about the whole of Finnish innovation system, we can see that although the national fund, the Sitra, invested 10 million euros as a capital investment in this company, that was far from enough. It's so expensive work to develop new drugs that 10 million is just something you can start with. And they would have needed significant investments from abroad, which they didn't get. And if we take a look at the firm level challenges, we can see why they didn't get it. International investors completely could kind of determine that this don't look like a lucrative business. They don't have their products actually ready yet. And they usually think about in terms of 5 years when they want to get paid back for their investments. And this wouldn't be able to materialize in the case of this company. Also, another national level hindrance in the development of the company was the fact that these kinds of substances were manufactured in Western Europe, but at the time, by the turn of the millennium, much of the production was being transferred from Western Finland and from the United States to China and India because it was very much cheaper to produce these substances there. And these people in this company thought that they would establish this company, this drug factory in Finland, but once they counted the prices of the end products in the markets and how much producing those substances would have cost in Finland, they came up to the conclusion that Finland is actually too expensive country to build a drug factory. It doesn't make sense. In Finland, labor legislation is such that it creates these costs. People have higher wages, social security payments. All these kind of made it a situation such that it was not kind of competitive to produce drugs in Finland. And finally, if we take a look at the supranational level, the company had to find collaborative partners from emerging third world countries, and that was very difficult in terms of cultural differences. Business negotiations with Indian companies didn't proceed quite well. I have a detailed analysis of that in one of my papers if you're interested in these sorts of issues. Also, they tried to establish joint projects with Chinese companies, but in China there was a major reorganization of pharmaceutical industry at the same time, and all was very mixed, although it was kind of possible to go on, but then they couldn't get the final agreements because of this reorganization of Chinese pharmaceutical area. So these very many problems in very different levels kind of had the end result that the company kind of had to scale down its business plans, its business models to something which is very unchallenging in a way and not that ambitious. So, but if we take the other company, it's kind of a reverse picture, reverse kind of development. This is a case of a reagent, originally an enzyme and reagent producer that is a spin-off from the Helsinki University of Technology in 1986. It's based on student work there. The students then, very soon after graduation, they established this company. It was very successful, and it was sold in 2010 to a major global US-based instrument company, Thermo Fisher Scientific. Products of these companies range from reagents and enzymes to instruments and whole systems used in biotechnological research laboratories. This has been a good business for owners of this company. Annual profit has been nearly 1 million euros, and the company over the years has annually grown very significantly, nearly 20% growth each year. And there are a couple of pictures that is a building of the company, main headquarters of this company in Helsinki, Espoo, and a couple of its products are pictured over there too. Trajectory of this company is very different from pharmaceutical company. This company started with much less ambitious plans. It started as import business. It didn't have products of its own at all. It kind of was agent for international enzyme producers and reagent producers, and sold those enzymes in Finland and Scandinavia. That's how it started. At the same time as it did this, the entrepreneurs and researchers of the company very actively get into the contact with enzyme producers all over the world, and actually they made learning visits, for instance, to New England Biolabs, which is the major enzyme producer located in the United States, to learn the business before they kind of entered in their own product development. They started their product development by the turn of 1990s together with Icelandic research groups, and they got their first own product on market in 1991. They went on diversifying their product portfolio during the 1990s, still having their products as different kinds of enzymes and different kinds of reagents used in polymerase chain reaction, which is a basic methodology used in biotechnology laboratories worldwide. Then they started offering diagnostic services for some Finnish customers, and they started developing not only enzymes but whole kits used in biotechnology laboratories. A kit is a kind of it's a package of different kinds of tools used in biotechnology laboratories. If you can kind of say that enzyme is one part of a kit, there are also other kinds of tools in kits, and those kits are then bought by researchers who do biotechnological research or biology research in research laboratories. Then during the 2000s, by help of partners from the United States, the company was able to start developing new kinds of instruments used in PCR in research laboratories, and developing these instruments was very successful, and so it became a major product for them. And after a couple of years, the major US company in healthcare equipment sector bought the company. So this is kind of a not that depressing example of how biotechnology can be developed also in a small country. And major advantages, if we take a look at the company's trajectory, are again kind of summarized in these three levels. On a firm level, to start with, the company started by acquiring early income through import business, so it was not dependent on external investors. Of course, this is something also to do with the area of biotechnology this company was working. It was not so capital intensive as developing drugs. So it was more easy to operate in this way, in this reagent business. Also, and this is what I already just said, that the product development costs of new enzymes and even new instruments and these things, they are much more cheaper than in pharmaceutical industry. The company was continually successful in networking. It was able to establish very useful collaborative projects with research groups coming from Finland, from the United States, from Iceland, from Germany, any place. And that's something this company could manage. While if we take a look at the pharmaceutical company, they had huge problems in that area. And one can say that these guys behind this company, they had good management skills. They kind of could evaluate because they were offered very many projects, and because they were central players in the reagent business and enzyme business. So they were offered very many kind of project ideas. Would you collaborate with us doing this or that? But they were able to see where kind of the lucrative business would be, and what would be the kind of initiatives that they want to go on with, and what they don't want to. If we look at the national level advantages, it's basically, I guess, the issue that they got a small amount of initial venture capital, but they really they didn't need too much of that any later, and so that was no hurdle. And finally, if we take at this business field on a supranational level, it was during the 1990s and 80s already. It was a very strongly growing business. PCR emerged as a technology in biotech area in the mid-1970s in the United States, and it really started to develop as a central technology used in biotech research during the early 1980s, and then the business related to PCR was very strongly growing, and also this company was able to jump into that bandwagon and develop its business very successfully. So just now, in order to end this presentation in time, a couple of conclusions. First, a little bit about limits of this study. On the basis of this kind of a case study approach, it is not possible to draw any kind of general conclusions about such a huge entity as National Innovation System in Finland. It is possible, however, to shed some light on some aspects of that innovation system and some specific area, which here is the biotechnology and more precisely pharmaceuticals and enzyme and reagent business. And also on the conditions of the kinds of actors that, at least in the Finnish innovation system in the area of biotechnology, are the most central, these small biotech companies. Because the industry is global, firms, however, encounter, I would say, all over the world, more or less similar kind of operational conditions. They have to be able, in some ways, to operate on a global basis. They need to have these kind of basic abilities and basic knowledge about their fields of business in order to succeed, in order to find partners, in order to do anything. And perhaps this is something that is transferable from the Finnish experience also to other countries. Then the last slide, if we kind of compare these two cases, we can point to some crucial issues illustrated by the case examples. First, relates to immatureness of innovations and businesses. That is something which is very easily seen in the case of biotechnology, in the case of pharmaceutical companies in Finland, not only in this case, but more generally. And if we think, for instance, policy measures or that should be taken, is that one should, and also if we think about universities, what universities might do when they try to figure out the possible commercial products sprouting from their research, they should be very cautious about this, and they should pay more attention to the ways in which they could create more value to innovations before commercializing them. Finland has made mistakes, I guess, in that it has, in pharmaceutical sector, tried to commercialize innovations all too early. So it could be, they should have been developed further within universities, and then only later stages perhaps commercialized if the development of technologies and products had been successful. Also, these examples point to the relevance of competitive environment that should be taken into account. If one is in a situation that one needs to compete with the emerging economies of China and India and Far East Asia and these sorts of things, that's kind of maybe very relevant in terms of where you can locate your activities, and then it seems to be that having certain activities in high-cost countries like Finland is simply out of question. You cannot produce products in a competitive prices. So then networking and being able to form collaborative networks on a global level seems to be a necessity in this kind of a network business. And also, it might be useful if one is trying to establish a company, trying to think about if it's possible to have early stage cash flow too, so that you could kind of have such kind of a business model that you earn some money from very early on, selling something, your competence or anything, but or establishing this sort of an import business or something, so that you wouldn't be so strongly dependent on external venture capitalists. But of course, if you work in certain areas, you cannot manage without capital investors, and then you should kind of think about the right time of establishing the company. This holds especially for the drug industry. And perhaps national policymakers can do something about these issues. At least they should think about how they could support firms' access to global markets. It's in large countries, it's perhaps a little bit easier than in Finland. In Finland, if we think about biotechnology, which is so kind of scattered area of technology and business, there are not many people in Finland who can master all these different specialisms in terms of businesses. So there should be some kind of ways in which these kind of competencies in relevant areas would be developed in the country. Then, if we think about university spin-off companies, it's also important that if those entrepreneurs who start the company are academics, they need really learn a lot, because that's a really different game, doing research and doing successful business, and that should be something that the researchers think about themselves, and also that kind of the universities and policymakers think about that it's a huge leap for the people, and perhaps it's not always kind of the most sensible thing to do, to leave your research at the university and jump into the business. It would be perhaps more sensible to hire a kind of real businessman to operate the business and remain by yourself in the university. And also, I would say that at least in Finland, there is a lesson to be learned, and perhaps it has already been learned, that and it relates to the capabilities and understanding when some innovation is mature enough for commercialization. And it clearly seems to me that in Finnish innovation system, where the major venture capitalist was the National Innovation Fund, Sitra, and it decided to spend most of its funding to pharmaceutical sector, there must have been people who really didn't understand the capital intensiveness of the business, and they perhaps thought that the process would be a little bit more easy than it actually was, and so perhaps quite large sum of money was wasted in this learning case. But anyway, so that was what I had to say to you today. So thank you for kind of your attention, and I'm happy to answer if you have any questions or take any comments which you may have.
Thank you, Professor Tuunainen. Now, please ask your questions and make comments. The floor is yours. You'll have to digest a little bit.
I think Finland is, in that case, it's a pleasant place to do research because access was very easy. I only called, first I emailed, but then I called to the CEOs of these companies and explained what this all is about, and they thought that, well, they have something to tell me. Even the company that was not that successful thought that there are lessons to be learned from what they have encountered. So they kind of thought that it's useful to distribute these experiences, and that's, I guess, that was perhaps the main motivation for them to be engaged in this research. But we also, in our research group, where I did my dissertation, we also had other kinds of experiences in trying to get access to companies, and I would say that in Finland it's quite easy to study those companies that are privately owned and that are very small, that are possibly owned by the operative management, because there are just kind of one or two people that you must discuss with, and they can open the door for you for everything, or then they immediately say that, sorry, but we don't want to be studied. So in both of these cases, the CEOs were also owners of these companies. But when we tried to study larger companies, it became very different, much more difficult. They have lawyers there. They are possibly owned by international other companies. And so it's much more harder to get access, and actually we haven't studied those kind of companies simply because it takes so long time to get an agreement if you can study or not, and then it can be that you are not able to publish your research results. So what sense does it then make to an academic to study something on the basis of which you cannot publish? But these small companies, they are, and those companies that are owned by the operative management, they are, I don't know, it would be interesting to hear how it is here. Have you any experience by yourself? I mean, if you...
It's difficult.
Yeah. It's even difficult in the United States. One of the professor where Yrjö Engeström, who was the leader of the research center where I did my PhD, had a professorship for something like 15 years in University of California in San Diego, and he did much of his empirical research in Finland precisely for the same reason. Difficulty of getting access to organizations in the United States, but very easy access in Finland. Yeah.
I have a question. I really like that you used two examples, one successful and quite much. But my question was about business skills. You mentioned that most cases they were from academia. One was successful in trading, and the other one they couldn't do it. And you said that, someone had it. Is it something natural, or maybe they just should, or maybe it's something about generation, or what the reason?
I wouldn't say it's natural. It's in the latter case where the managers were more kind of skilled in that. They, from very early on, they started learning those skills. It kind of was a gradual learning experience for them. For instance, when they were still students at the Helsinki University of Technology, they used their studies to make a draft plan for an enzyme factory to be located in Finland. So they kind of familiarized themselves already very early on these kind of concrete issues that come up when you're an entrepreneur and when you enter kind of the business area. And then when they established the company, they immediately contacted the major, and this is quite interesting, they contacted the major enzyme productions in the whole world as a new kind of 22-year-old masters of technology, they sent emails. We are planning to do something like this. We would learn how you make enzymes in such a way that you are able to sell them on a global basis. They contacted German company, they contacted companies in the United States, and New England Biolab, which is a major actor, it said, okay, come visit us. And one of the entrepreneurs spent half a year there just purifying enzymes and learning all the issues that must be taken into account when you make these kind of products. And then they continued this collaboration relationship with New England Biolabs in the years to come, when they started import into Scandinavia the products of New England Biolabs. And they learned by so doing kind of the business skills. But this pharmaceutical company, they were academics who then established the company without having any kind of background, without learning anything. They kind of started learning once they had a company. And also they spent a lot of time in learning that. They used international and Finnish consultants in helping them in business negotiations, for instance, because they have never been in such situations. So they had kind of helpers there, but still it didn't work out too well. Also, perhaps it has to do with the fact that they were operating with people coming from very different cultures. The reagent company operated mostly in Western Europe and in the United States, so kind of the culture is more or less similar than compared with China and India.
Yes, Yuri?
Thank you so much for your very interesting and informative presentation. My question deals with the theoretical background of your research. I'm particularly interested in a kind of, maybe you can deliver information about this issue. If there exists a kind of Finnish school of STS studies, this Finnish environmental background for the development of these studies. I can give an example of conceptual history in Finnish way, where they established a school, exchanges, official English journal devoted to this issue. Do you have such an environment at your university?
Yeah.
Simply graduate school sometimes.
Background for this research, and I didn't say too much about it, is it's a Center for Activity Theory and Developmental Work Research, which is a research unit which is based in Department of Education at the University of Helsinki, and it has a kind of a paradigmatic theoretical approach which is based on activity theory, part of which that theory comes from Russia, work of Lev Vygotsky, developmental psychology of Lev Vygotsky, and then Alexei Leontiev's further work on that. And it was then, during the 1980s and 1990s, further developed in Western countries. In the United States, the professor I just mentioned, who spent 15 years in UCSD, is one of the main figures developing this kind of an Finnish activity, or let's say Scandinavian, because there are also in other Scandinavian countries people doing same kind of approach. So they kind of developed a certain way of studying activities, human activities. And our understanding then, when we study innovation, is that we're studying, and here is also a little bit influence from actor network theory. It's a kind of combination of these two theoretical strands. How we have been approached innovation in terms of empirical research. We are studying innovation networks, and we regard innovation networks as a kind of object-oriented networks, in a sense that within an innovation network you have heterogeneous actors, different kinds of people or organizations coming from different kinds of backgrounds, having different kinds of knowledge, having different kinds of technologies and all these things, and they kind of, in innovation networks, usually they form some sort of a complementary whole by using which you can materialize certain ideas, kind of build certain objects, shared objects. So object-orientedness of activity, which is kind of very central to activity theory, is built in this idea. So that's kind of I would say, background how we approach these companies and their developmental projects. We have analyzed, for instance, the reagent and enzyme companies' different product development projects separately, and how different actors contribute to the kind of materialization of the joint object. Perhaps that answered to some degree, at least, to your.
Just maybe if you can, if you would like to specify this connection between neoantigen, it seems that there is a kind of cognitive interest here, because neoantigen or the school is more cognitive oriented.
Mm-hmm.
So in this case, probably it is more interested in construction of some kind of epistemic communities.
Yeah, and what is
entity and not a kind of purely organizational analysis.
Yeah, and what is also important in the way we kind of analyze these networks, we pay close attention to materialities of so it's not only cognitive issues, it's not only social issues or epistemic issues, it's also because these kinds of research areas we are talking about, it's material production, material kind of research. I mean, you manipulate entities. That's what biotechnology is all about. So materialities and also resistance of materials. Different material entities don't always work as researchers want to make them operate. So there is these kind of resistances and kind of different things that you must work around in order to make something to operate. But this we have kind of quite strongly also take account of this material side of activities.
Did it play any role in this research? Have
Yeah.
you encountered these issues with materiality that would?
Well, yes, especially in a sense, in the case of the first company where the technology was not finalized enough. You could very easily see that it just didn't work. I mean, the technology, and although they tried to develop that technology further with another Finnish company, it still didn't work well enough because of impurities and these sorts of issues. But here we didn't study the actual laboratory practice of developing that technology. So we were not present in the research laboratories, and I cannot say too much about that, about kind of practicalities that were there. But evidently that was one of the major reasons why the company was not successful.
Lector,
I was just wondering, you said in the beginning that when you started this research, you kind of felt that this was a traditional lab study. This was or it was linked to traditional lab studies. And there is a feeling, at least among some people who have been in that field for 30 years now, that there's not much to be produced, studying laboratories in the United States or France or Germany. While in Russia, for example, it's vice versa. It's very interesting because there was no studies that were done, and actually that's why we encourage students to go and do that. And so the question to you is twofold. The first one is whether you thought when you were doing that study of two firms that something was intensely interesting in there, and you were closer to the Russian case than to, let's say, American case. And second is, if you found that something interesting, how would you briefly describe the contribution you did in comparison to the usual lab study or lab firm study?
Well, in this case, we didn't do the lab study. My reference to lab studies was, it had to do with my dissertation that started as a kind of lab study. And there, if I think that one, well, I would say my contribution to science and technology studies from lab perspective some way was to connect what was done in the laboratory to the external world. That's also something that actor network theory already for a long time ago kind of did. The early ethnographies of laboratories took place inside the walls of laboratories. And what I did then in my study, already of course knowing that what Bruno Latour and others had done, and also what symbolic interactionists had done, because they had this kind of a similar kind of an idea of articulation work between laboratory level and then the kind of social world level outside the laboratories. Joan Fujimura, for instance, speaks about articulation work. So I kind of wanted to analyze also connections between external world and laboratory, and how I did this was that in the laboratory part of my work, I used as an analytical device the system of the concept of experimental system developed at that time by Hans-Jörg Reinberger. And Hans-Jörg Reinberger conceptualizes experimental system as one which has epistemic object, and then there is technical things that you kind of manage or use in materializing the epistemic object or epistemic thing, as he calls it. What I added to this was, and this comes from the activity theoretical perspective and from the concept of object, I added kind of I call it application object. We have an object in research laboratory which is at the same time epistemic in terms of creating new knowledge about something. But if we are in biotechnology lab, in that biotechnology laboratory I studied, there is also very evidently from the very beginning kind of the societal application object too. Kind of I called it application object. And it's something which will eventually be transferred to the society. And in my case, what I studied, it was a virus-resistant potato variety. It was a research group operating in plant biotechnology area, and what it tried to do was that it studied virus resistance phenomenon in a potato, and at the same time, while increasing knowledge on the phenomenon, it tried to develop by using biotechnological means the virus-resistant potato variety that could eventually be used by farmers in Europe, for instance. And so this, I would say, was at least when it comes to the lab studies, kind of what I did. This is not, perhaps if we kind of look at what Latour wrote about Pasteur, this is not kind of so original, perhaps, But still, it was original in terms of epistemic systems, at least how Hans-Jörg Reinberger spoke about them. And so. Yeah.
Well, we know each other.
Yeah, yeah.
But to come back, I might have missed, sorry, when we described fieldwork in these two firms. For example, in the reagent firm, was it only interviews or were you allowed to discuss observations?
No, we didn't any ethnographical studies or work in these cases. We made interviews and then we had different kinds of documents. Yeah, yeah.
I thought somehow that they allowed you because you were asking the question of students. How easy it is to get access?
Yeah, it would be very interesting to do ethnographic study, but we didn't simply have time for that. We had to kind of use other means, but doctoral students are in a position that they have more time, perhaps, and they have more time to spend in doing ethnographical studies. That's also their advantage.
But who was, if I may ask, who was kind of pushing you to act in a hurried way? In the sense, when most medical studies, lab studies or firm studies is ethnography or lab or a firm, and the study chooses just to collect interviews and look at the documents, and then why would the researcher abandon the best method and go for the second method?
We wanted to get the project done within 3 years and get publications out. Well, I don't know. Perhaps it would have been interesting, and I don't know. We didn't ask from the very beginning. Do you kind of stand it if we kind of shadow you all the time? If we want to study these sorts of companies and their evolution, it would have been difficult in the sense that the usefulness of laboratory studies is that you have the certain place where things usually happen. You have that laboratory and you can go there. But if you have studied ethnographically, for instance, the reagent firm, you should have actually followed on an airplane with following the CEO all over the world all the time, because he was traveling something like more than 100 days per year, and in order to collect ethnographic data on kind of, because we were interested in that project not anymore that much about what happens in a laboratory, but how these companies construct their networks and what happens during the trajectories of these companies. So, yeah, that would have been kind of. It's not that the kind of economical way to study, to follow somebody who's, because networking in business is that sort of activity. You are always somewhere else than in your kind of headquarters and home.
Are you planning to continue somehow this research, or if not, what other your research plans you have in mind?
Now I have 2 projects going on. One can say that all my research kind of are interlinked in some way or another, but I'm not continuing this in kind of terms I've just described to you. My current projects are these. The first of them addresses what, at least in Finland, is called the third mission of the university. The first mission is research, and the second mission is education, and what we call as a third mission is the kind of societal service, kind of the contribution of the university to the society. Of course, one can say that it takes place already through research and it takes place through education, but still it's kind of conceptualized and spoke about as a different mission. what we are doing in that project is that we are studying different kinds of forms and mechanisms university researchers collaborate with societal stakeholders in different areas. We are studying not that much technological sciences, simply because if we take a look at the science and technology studies field, there is abundance of research on commercialization, on biotechnology, on ICT and these kinds of issues. What is lacking is studies on social sciences, humanities, and that's where we are going to kind of pay attention. We are going, and actually we have started doing 3 case studies. One comes from multidisciplinary urban studies, which is urban geography and urban sociology. The second area we are going to study is Finno-Ugric and Baltic Finnish languages. It's very interesting. Those researchers are in that area collaborating with other kind of societal actors to revitalize dying languages. Inari-Saami language in Finnish Lapland, for instance, and Karelian language in Russia. Then the third case is learning difficulties in young children. That's interesting because they are using computer-mediated games as therapeutic means to help children to overcome their learning difficulties, and that's very strongly tied to Finnish educational system and daycare system. So that's one empirical work I'm involved, and so that's about forms of collaboration between researchers and societal actors. The other is more policy-oriented study. It's about recent changes in Finnish science and technology and innovation funding systems and the ways in which these changes play themselves out and effect on the activities at the university level and activities at the department and research group level. We want to analyze how these changes either help or inhibit innovation in different areas or renewal of certain fields of study in universities. We haven't yet decided for sure the cases we will study there, but we have started collecting research data on the policy level and on the university level. And we are hoping to do 10 case studies in 5 areas of science. And those areas could be something like at least one from humanities and social sciences, at least 1 or 2 from, let's say, natural sciences, basic kind of natural sciences, chemistry or something which is at the same time relevant from the point of view of Finnish industry. And chemistry, for instance, is one of those from the point of view of forest industry. Then we want to have there, just because of Nokia and all this kind of electronics industry in Finland, we want to have one case of coming from an ICT area, and perhaps one from some sort of bio something. We don't know exactly, but anyway. So, and then we are going to have different kinds of universities. So we want to have such kind of case study pairs that we have, let's say, biotechnology case from the University of Helsinki and biotechnology case from the University of Joensuu. 2 very different kinds of universities, so that we are also able to compare different university contexts with one another, because these universities are nowadays in Finland developing different kinds of internal mechanisms of strategic management, of allocating resources and these sorts of things. So the differences between universities is relevant to take into account. So that's the second research project, and this is the project where I'm personally involved also in doing empirical data collection and empirical research and data analysis. And in the other project, I'm more or less supervisor of dissertations. And by the way, I should also say that I have a new student there who's studying biobanks, Finnish biobanks. That is an emerging activity in Finland, which will be hopefully, and I guess will be institutionalized as some sort of routine basis kind of activities are being built on how biobanks are managed in Finland, and she's studying biobanks. So that's kind of the fourth case there.
Other questions? Comments? Exhausted? Yeah, okay.
Did I understand right that you actually build the networks theoretically data, you build the heterogeneous networks, and you do some network analysis, or you use
No.
just as theoretical, therefore?
No, actor network theory was more or less of an inspiration, but the way we have been studying networks, they are not networks in active theoretical sense. They are kind of networks of organizations or actors, I mean human actors, but who then manipulate material entities, and those material entities then may not always work as the researchers or technologists would like to. So they have kind of activities in some sense, but they are a little bit different kinds of actors in our networks than perhaps would be the case with Latour.
Okay, now let's thank Juha.
Thank you.